So here's section 2.4, the distributive property. So the goal for this lesson is to multiply a constant monomial and polynomial using what we call the distributive property. So before we get into what the distributive property is, we're going to consider the following. What is the area of the shaded region of the given diagram on the right? So I have this diagram here on the right. It consists of these two rectangles, and I'm asking you for what's the area of this diagram. So if we consider the entire diagram as a whole, one whole big shape, I'll just call this option 1. Oh, option number 1. And option number 1, let's just fix a couple of things here. Let's just hide the taskbar. There we go. So option number 1, we're going to take the entire shape. So as a whole, the area of this shape would be the length and its width. So the length here would be 5 plus 2, and the width here is 3. So I'm going to say here, this is going to be, so 5 plus 2 times 3, and I'll put the 3 in the front. And if you follow BEDMAS rules, you'd have 3, 5 plus 2 is 7, so 7 in the brackets, and then 3 times 7 is 21. Okay? But let's look at it a different way. Let's call the different way option number 2. Option number 2, we'll look at this shape as separate rectangles. Okay, so as separate rectangles, I would look at the first rectangle on the left. So I have the length of 5 and a width of 3. And so I would calculate that to be 3 times 5. And I'm going to add that number to the area of the second rectangle. So the second rectangle has one dimension here of 2. And again, it shares that same dimension over here of 3. So 3 times 5 plus 3 times 2. And that equals 15 for the first term, plus 6 for the second term. My answer is 21. What do we notice? Well, it turns out that both answers are the same, but we approached it in two different ways. So what makes the distributive property? Well, you look at this carefully. Notice I have 3 times 5 plus 2, and over here it looks like this 3 has been distributed, 3 times 5 and 3 times 2. Well, that's what the distributive property is. So here on this side, I'm just going to write a little thing here. So if you have this, call it say the distributive property. It's called distributive because it's like you're distributing that monomial. So 3 times 5 plus 2. We're distributing that number. So it's like I'm going to take this 3, I'm going to distribute it inside this bracket. Okay, then like think of what's the word distribution? Like you're giving away something. Like you're gonna give someone something. So you have all this stuff here outside. You're gonna give it to, let's say, put it inside this little room here with other things. You're gonna give it to these other people. Okay, you're gonna distribute this 3 times 5 and 3 times 2. So that's what's happening. So when you're distributing it, you are multiplying it with the terms inside. Okay, so let's just, before we even go into the formal rule of the distributive property, let's just do a couple of things here. So this is an activity that I'd like you to complete. So pause the video. I want to see if you can complete the activity. Okay, so hopefully you had a chance to complete the activity. I'm just going to go through it really quick. Basically, start off with an expression, 2 times x plus 1. Give me a verbal description. Well, this is just the two groups of x plus 1, right? So 2 times this bracket. So if I had two groups of x plus 1, I can express that as an addition by saying the first group of x plus 1 plus the second group of x plus 1. And then, like we did in the beginning of our cycle, you just collect all the like terms. So you collect the x's, you get 2x. You collect the 1's, and you get a 2. So your simplified answer is 2x plus 2. What about the next one? So here we have 4 times x minus 2, which is 4 groups of x minus 2. And if I want to show that using addition, I would say x minus 2 plus x minus 2 plus x minus 2 plus x minus 2 equals. Collect your like terms. So let's first remove the brackets. So we have x minus 2 plus x minus 2 plus x minus 2 plus x minus 2. Collect the x's together. I have 4 of them, so that will be 4x. Then I have negative 2, take away 2, take away 2, take away 2, which will give me take away for negative 8. So there it is. Negative 4x minus 8 is my simplified form. Okay, try the next one. Here I have 3 groups of x squared plus 2x. So we're just looking at 3 times this bracket here. So 3 of those brackets. So that will, as an addition form, writing it through using addition, I can express this as x squared plus 2x plus x squared plus 2x plus x squared plus 2x. Okay, and you collect your like terms. I have 3x squareds here. So I'm going to write here 3x squared. And I have 2x plus 2x plus 2x. Add those coefficients and I get 6x. Okay, so my simplified form is 3x squared plus 6x. And I think you can start to see clearly the distributive property where you're ending up taking the number that's on the outside and multiplying it with each term on the inside. Okay, so you might be able to get the final answer for this right away, but let's just go through it one more time here. So we have 2 groups of x squared minus x plus 3. If I write that as an addition, I would have x squared minus x plus 3 plus x squared minus x plus 3. Collect your like terms. So again, the variables with the same exponent, so x squared plus x squared is 2x squared. Minus x is minus 2x, and 3 plus 3 is 6. So my simplified form is 2x squared minus 2x plus 6. So what do you notice between the expression and the simplified answer? The simplified answer takes the, let's call it this coefficient, from the expression and multiplies it with every term inside the bracket. Let's write that properly, with every term inside the bracket. Okay, and that's all the distributive property. That's what it is. So now I can just show you formally what this looks like. So we can expand brackets by using what we call the distributive law or distributive property. So that says if you have this number in front of the bracket, and inside your bracket you have b plus c, so 2 other numbers or 2 other terms, you can take that term in the front and you can multiply that term with the terms inside the bracket. So you have a times b plus a times c. Okay, so let's go through some examples. Example 1, multiplying a polynomial by a number. Each term of the polynomial is multiplied by the number in front of the brackets. In other words, multiply the value in front of the brackets by everything inside the brackets. Okay, so what I have here for the first one is 5 times 9x minus 8 inside brackets. So you take that 5 and you multiply it with every term inside the bracket. So here I'll have 5 times 9x, and then I'm going to have minus 5 times 8. Okay, and I'm going to multiply those out. So 5 times 9 is 45x, and 5 times 8 is 40, so minus 40. Okay, and that's it. That's how you distribute. Okay. Let's look at this one here. So let's take this number in front of the bracket. We multiply it with every term inside. That's why I'm drawing these connecting arrows. So when I do that first multiplication, now be careful. With these negative signs, it's a good idea to put everything in brackets. So I'm going to start off by saying negative 10 times negative 2x squared. Then we're going to add the next term, so negative 10 times 2x. And then we're going to, again, add this last bit here, negative 10 times negative 3. Okay, and then we are going to have to multiply all of these terms. So negative 10 times negative 2 is positive 20x squared. And then we have negative 10 times 2x is negative 20x. So instead of saying plus negative 20, I'm going to say just minus 20x. And then negative 10 times negative 3 is positive 30. So here I'll have positive plus 30 at the end. And there you go. So instead of just multiplying a polynomial by a constant number, we can go one step further and multiply by a monomial. Okay, so it's very simple, right? This is just a constant in front. Now we're going to multiply by a monomial term. So each term of the polynomial is multiplied by the monomial in front of the brackets. So it's the same idea with the numbers. So instead of a number, you just have a monomial. So the rule is to multiply a polynomial by a monomial, we multiply the coefficients and add the exponents of the variables with the same base. Okay, so let's look at the first one. Here I have 7x times x plus y. So all you're doing is you're taking this monomial and multiplying it with every term on the inside. Okay, so what you have here is 7x times what you have inside x plus 7x times y. Simplify. 7x times x is 7. Multiply the coefficients. There's an invisible 1 here, so 7 times 1 is 7. X times x, add their exponents. It's 2. 1 plus 1 is 2, so 7x squared. Here in the next term, I have 7xy, and so there are no other variables to multiply here, so I'll leave it as 7xy. Okay. Looking at the next one, part B. So again, take the entire monomial in front of the bracket and multiply it with each term inside the bracket. So here I'm going to have negative 3a times a plus negative 3a times b. So again, when you're doing this, I recommend keeping the terms inside brackets, and you're separating your terms by a plus sign. Okay, then you're going to change the signs in case you need to change them after you finish multiplying your brackets. So negative 3a times a is negative 3a squared. And then negative 3ab is just, so plus negative 3ab, but I don't want that plus negative, I will just say minus. So plus minus becomes minus 3ab. Remember, opposite signs make always a minus. Same signs being multiplied is always a plus. Okay, let's go to part C. All right, let's try this one. So again, multiply this monomial with the terms inside the bracket. So what we have here is 14x times x squared plus 14x times negative, so again, there's a minus sign in there, so that's why I'm choosing to put the minus sign inside the bracket. So minus x to the exponent 4, and you just separate your terms with a plus sign in between. So here, when I multiply these brackets now, these parts, 14x times x squared is 14. Remember, invisible exponent of 1, so you add the exponents, so I get x cubed plus 14 times negative 1 is negative 14. x times x to the power of 4 is x to the power of 5. Okay, now I'm going to remove the bracket here. That's going to become a minus, but also keep in mind, okay, let's write it that way first. So 14x cubed minus 14x to the exponent 5. But ordering is important. Remember what I said about proper form? Put the highest exponent first. So even if the coefficient is negative, put it first. 14 times x to the exponent 5, and then plus 14x cubed. Okay, next one. Now, multiply the monomial. Now we have monomials and then monomials inside as well, multiple variables, same process, okay? So here I have 2ab multiplied by 3a squared b plus 2ab multiplied by negative 7ab. When I expand, 2 times 3 is 6, a times a squared is a cubed, b times b is b squared, plus. Now at this point, if you choose to just simplify your work a little bit, skipping a couple of steps, that's fine. If I do 2 times negative 7, I get minus 14. A times a is a squared, and b times b is b squared. And there you go. Check to see if we can combine these two. Apparently we cannot. Okay, so they get different exponents for the a. Next question. Again, increasing the complexity by adding one more term inside the bracket. So my monomial in front is going to be multiplied 3 times because there are 3 terms inside the bracket. So when I multiply them, and again put everything in brackets, so negative 5x squared y times 4xy cubed plus negative 5x squared y times negative 3x to the exponent 4. Don't forget that's this minus sign will go here. And then I have plus negative 5x squared y times minus 2y. Okay. Then we expand, multiply everything. So negative 5x squared y times 4xy cubed. Multiply the coefficients, negative 20. X squared times x is x cubed. Y times y cubed is y to the exponent 4. Don't forget that invisible 1. Then we have negative 5 times negative 3, which is positive 15. X squared times x4 is x to the power of 6. Then I have y by itself. And then the last term here, negative 5 times negative 2 is positive 10. And then x squared as x, this is only by itself, so x squared. And then y times y is y squared. There you go. So whenever you apply the distributive law, this process, and I mentioned it briefly, this process you are performing is called expanding. It's expanding, okay? It's like you imagine this is like you were expanding the number of terms, we're increasing removing those brackets and we're creating this expanded form, okay? So it's when I say expand each of the following means use the distributive property, okay? So expand, again, multiply the 5 with everything inside. So I'm just going to go a little bit faster to finish this video. So 5x squared, 5 times 3 is 15, so plus 15x. 5 times 10 is 50, don't forget the minus sign, so minus 50. Next one here, 2 times negative 3x is negative 6x. 2 times x squared is 2x squared, so plus 2x squared. And 2 times minus 4 is minus 8. Again, ordering counts, so put the 2x squared first, then your lower degree terms, so minus 6x and minus 8. Part C, multiply, negative 3 times negative 7 is positive 21x squared. Negative 3 times 4x is negative 12x, or minus 12x. Part D, there's a trinomial inside the bracket now. More negative sign, so be careful. So negative 7x times negative x squared, it's going to produce positive 7x cubed. So negative 7x times negative 8x is going to produce plus 56x squared. And then negative 7x times negative 9 is 63. So positive 63 because it's a double negative x. Okay, and the terms are in order by the highest degree. Part E. Okay, so we now have a couple of distributive expanding parts. So we're going to do this part first. Then we're going to do this part next. Okay, so the first part, we have 4x squared. 4 times minus 5x is minus 20x. And that takes care of the first part. So, and we're not going to distribute the 4 with anything else, right? It's only what you're only distributing it within the brackets that it's attached to. Okay. Notice there's a plus sign in the middle, so that's why the 4 is not going to cross over to anywhere else. Now in the other square bracket here, I have 6x times 3x, which is plus 18x squared. 6x times minus 2x squared is minus 12x cubed, and 6x times negative 2 is minus 12x. Okay, now you look for like terms that we can collect. 4x squared and 18x squared are like terms. Okay, and I'm going to put the one with the highest degree on the first in the first position here. So I'm going to have minus 12x cubed. 4x squared plus 18x squared, add their coefficients. So 18 plus 4 is 22. 22x squared. And don't forget about minus 20x and minus 12x are also like terms, which will give me minus 32x. Okay, and don't forget, you're not going to be adding exponents here when you're adding and subtracting. You're just going to keep the same variable and exponent, but just change the coefficients. And let's look at our very last one. Okay, so again, we're going to do this part first. So we have here 5 times 3y, which is 15y. 5 times 8 is negative 40. 5 times minus 2y squared is minus 10y squared. Okay, now you have to be very, very careful because we have a negative sign here now instead of a positive sign. So that means you're going to multiply with each of these terms a negative 4 instead of a positive 4. Okay, so sometimes it might help us. I'd like to just do what I did earlier, put the plus sign, put everything in brackets, so minus 4 times minus 2y squared, and then plus minus 4 times minus 10. Okay, simplify this, so 15y minus 40 minus 10y squared, that stays the same. Here I have minus 4 times minus 2, which is positive 8, so plus 8y squared. And here I have minus 4 times minus 10, which is positive 40, so plus 40. Okay, collect like terms. These constants cancel each other out. One's negative, one is positive. And then I have to add these two terms because they have a common variable and exponent, so y squared is there. Add their coefficients, negative 10 plus 8 is negative 2. And don't forget the y squared, so negative 2y squared. And then I have 15y afterward from here. Okay. All right, so let's just do one application problem here. So application, determine an expression in simplified form for the area of the shaded region. So I'm interested in this kind of border area here. So the area of this border I can find by using the area of the outside, that outside rim, or this part here, and I can subtract the area of the rectangle for the inside part here. So let's see, let's call this area an I for inside, O for outside, I for inside. Okay, so the expression is going to be the area of the outside minus the area of the inside. Okay, but first I need the area of the outside. So the area of the outside is equal to length times width, and I'm going to use expressions since I have no numbers. So what the outside is, the length is 3x plus 2 times the width, which is 4x. Okay, so 4x times 3x plus 2. Use the distributive property. 4x times 3x is 12x squared. 4x times 2 is 8x. Let's now look for the area of the inside. The area of the inside is going to be, again, length times width of that rectangle. The length is going to be x plus 2, and the width is going to be x. So it's going to be x times x plus 2. I'm just putting it in order so that the monomial is first and then the polynomial is in the brackets. Okay, expand. X times x is x squared. X times 2 is 2x. Now, I want to calculate the area of the outside minus the area of the inside. So I'm going to write the area of the outside, 12x squared plus 8x. I'm going to subtract the area of the inside. So I'm going to put the area of the inside in brackets. And inside my brackets, I'm going to put x squared plus 2x. Okay, we're not done yet. I have to simplify this. Now, whenever you see this minus sign in front of a bracket, okay, there are a couple of ways you can think about it. One, invisible 1 again. There's another invisible 1. Just distribute a negative 1 with each of these two terms inside. Okay. Or a simpler way of saying this is, but you do have to memorize it, is that if you see a minus sign in front of that bracket, all you're doing is you're changing the signs inside the bracket. So this becomes minus x squared. If it's a positive x squared, it becomes a minus x squared. And if it's a plus 2x, it becomes minus 2x. That's all you're doing. Okay, and then you have what I have here in the beginning is 12x squared plus 8x, and that doesn't change. Okay, so even if you did think of the invisible 1, you can do negative 1 times x squared, which is to give you minus x squared, which is what I have here. If you did negative 1 times 2x, you get minus 2x, which is what I already have here. Okay, the 12x squared, collect like terms, 12 minus 1 is 11, so 11x squared. And 8 minus 2 is positive 6, so plus 6x. That is the expression for the shaded area. And we're done.